Good afternoon. Today you will be hearing our senior project presentation, that is SDSU basketball practice facility. My name is Gilbert Angel. My group members' names are Thalia Aguirre, Bryan Salguero, Ocatavio Barranco, and Shawn. For our table of contents, we will give you a brief introduction, then we'll move on to site work, hydrology study, foundation design, retaining wall, structural design, construction schedule, and we will finalize with an estimate. Little background on our project. This was a design build. San Diego State in this case is the owner, as you can see in the diagram. Right below that is EGCS Incorporated, which stands for Engineering and General Contracting Services. Right below that you can see the project team. As a structure engineer we have Bryan, and then Thalia as the co-structure engineer and grading specialist. In the middle is myself, Gilbert. I was in charge of construction engineering. Then we have Shawn in charge of foundation and retaining wall. Then we have Ocatavio Barranco as a water resources engineer. So our project consisted of designing a project with the main focus on structure engineering, foundations, retaining wall, a schedule, a project estimate, and a hydrology study. Now we'll be touching on site work. In this slide we have site logistics. Right on the left hand side we have our site logistics plan. If you see the area of construction and the red dotted lines, that would be our fence, that would be our boundary during construction phase. The green blocks there are 2 gates, and if you see right in the blue, that would be a temporary barricade that was proposed by EGCS in case of safety for our students. Then on the right hand side we have our laid down area that was proposed in the RFP, and we followed that accordingly. Here we have our demolition plan. On the green there you see the brush that will be demoed, which is about 18,000 cubic yards. Right below that we have our concrete bleachers. Those will have to be demoed, which is a total of 15,000 cubic yards. On the blue blocks there, those are existing buildings that will have to be relocated. You can see in the picture there on the circles. Also we have the green lines there, that represents a storm drain that would have to be relocated for the building. Then also we have water lines that would have to be demoed and relocated for future project. Here we have a profile view for the bleachers. Here we can also see the proposed grade elevation for the basketball facility, which will consist as the same grade level as the existing parking lot L. That elevation will start at 387 feet.
Water study. Water study conducted for this project is conducted using the rational method equation Q equals CIA. C being the runoff coefficients, I being the rainfall intensity, and A being the area of the site. The first step of the water study was to determine the runoff coefficients for the construction site. The runoff coefficients used for the site were those of a business neighborhood area. The runoff coefficient was 0.70 respectively. Using the calculated runoff coefficient, new runoff coefficients were calculated for each design period. These design periods being 25, 50, and 100-year design periods. The original coefficient of 0.7 was recalculated using the correction coefficients for each design period. These coefficients will be used to determine the flow rate. Time of concentration for the site was determined next using the time of concentration equation shown. It was determined that 11 minutes was the average time of concentration for the water flow for all of the design periods. Time of concentration of 11 minutes was used to determine the rainfall intensity. Using the San Diego County Hydrology Manual, values for P6 and P24 were determined by analyzing the isopluvial maps. Final flow rate for the site was determined, and the design year period chosen for the site was that of 50 years, following Hydrology Manual regulations. Results. The water study rendered a flow of 3.4 cubic feet per second for a 25-year design period, a flow of 3.71 cubic feet per second for a 50-year design period, and the flow of 4.83 cubic feet per second for a 100-year design period. The estimated diameter size for the drainage should be 8 inches for the design flow. but following code regulations, we calculated that 18-inch drainage pipes should be the minimum.
The next step for the project is to determine the foundation design. In order to determine the foundation size and type for the SDSU practice facility, it is important to determine the soil characteristics. A cone penetration test, or CPT, was ordered. In the CPT test, a cone is driven into the soil by a hydraulic ram, and instruments measure the resistance to penetration, friction, and pore pressure. Tests were recorded every 5/100ths of a meter for a total depth of 20 meters. Using the chart created, the phi angle, or angle of friction, was calculated. Terzaki's equations were used to calculate the bearing capacity, while Schmerman's method was used to calculate the total settlement caused by the foundation and loading. Here is an example of a foundation designed for the largest load of the facility. The dimensions are 5 feet by 5 feet by 2 feet, and it sits 5 feet beneath the soil. It complies with the constraints of Terzaki's equations and Schmerman's method and is reinforced with steel. The retaining wall is another big aspect of this project. The first step to designing our retaining wall is selecting the type of wall to best fit our facility. Because the Aztec Recreation Center is sitting at the top of our construction site, a soil nail wall was designed. This allows for construction of the wall to work from the top down as not to compromise the safety of the recreation center, and less large machinery is needed, which allows for full accessibility of the walkways above. The retaining wall is comprised of a 6-inch thick shotcrete temporary facing with an 8-inch concrete permanent facing. The permanent facing is reinforced with steel mesh and whaler bars. The images in this slide demonstrate the design of the retaining wall. There are 10 21-foot epoxy-coated nails spaced at 5 feet horizontally and vertically. The nails are inclined at an angle of 15 degrees for stability.
Now we are going to talk about the structure. Based on specifications explained for the San Diego State University Basketball Practice Facility, Project 6722, a sports facility is to be designed and built in parking lot L, next to existing viejas. RFP requirements. Some of the requirements we had to design for were a full basketball court with NCAA dimension standards, plus 10-foot extra clearance all around the court, 35 to 40-foot high clearances. We designed for 40-foot high from the floor to the ceiling of the basketball court, a 1,500 to 2,000 square foot weight room, players, coaches, and returning pro players' locker rooms, video editing and press rooms, medicine room, and team lounges, all with enough square footage. The design. Based on research and information, our two top design options were a steel or reinforced concrete structure. After viewing pros and cons, it was decided to proceed with a steel frame structure. Steel advantages. We chose a steel design because of its benefits over reinforced concrete. Some are listed here. First is its strength. It doesn't deform or bend due to regular weather. Its properties don't change as those of reinforced concrete structures. It's at full strength immediately after installation. It's relatively lightweight compared to concrete or other materials. It has very high durability and a modern appearance. Prefabrication allows for quick access to materials and economic. Establishing the design. The design will be referencing the American Institute of Steel Construction, the AISC, which has been a national standard for decades, along with the structural steel design process. Now the floor plan. Here is our basic floor plan. The width 122 feet with a length of 150 feet. There is a height of 40 feet where the court is situated, while the rooms have two 20-foot levels. Our first floor has current team necessities, while coaches, offices, video rooms are on the second. The addition of a second floor. A complete second floor was added to maximize space utility and for design purposes. It allowed for bigger rooms and open space in both floors. It also aided in distributing loads equally throughout the.
The W shape made from A992 steel was chosen because it is the most economical, prefabricated, and standardized shape used during steel design of columns and beams. The first clip shows the placements of the columns in its sizes based on the grid. The ones on the perimeter are the same section, W10 by 33. The second clip shows the second floor placements of the beams and girders. their sizes and locations. The joists are offset 5 feet and the basketball court girders were designed horizontally to support the load of the heavy beam on the center of the court to aid in distribution of the loads. AutoCAD was a program of choice to set up the grid and to design the floor plan. Steel design is about selecting the lightest steel beam that will support the load without exceeding the bending strength or shear strength of the material and without exceeding the maximum allowable deflection for the beam. To select the proper beam size for the basketball facility building, we need to identify all loads and design constraints. Dead load and live load were considered, but wind load was negligent, since it is in a bowl of the main wind streams do not affect the structure. Seismic load were included in the foundation, but for the steel structure, the AISC manual does not provide detailed specifications for designing structures subject to seismic loads. After calculating the required strength, we selected sections that can take more load to prevent from buckling. We verified our sections by recalculating the nominal load by including the beam weight. This is the method of plastic design which we use for the steel structure.
Now we will be talking about the proposed schedule to complete the SDSU practice facility. An overview of our schedule, the total duration of the project will be 537 days, 24 months, which is equivalent to 2 years. Our start date is set for September 7, 2012, and our finish date is September 29 of 2014, which includes our design and construction phase. Some of our milestones were 50% submittal, which was submitted in November the 2nd of 2012. Then our final submittal submitted last week, which was 12/7/2012. Then we had our conference presentations the next day on December the 8th of 2012. And now here we had to assume some milestones for our schedule was having an award date set for January 4th of 2013. In addition to that, our notice to proceed in order to start construction, a milestone would be starting in April the 1st of 2013. Now construction phase should be completed by September 19 of 2014, and then finalizing and closing documents will be big in order to turn over our project by September 29 of 2014. Now we will be touching on the construction estimate for the facility. In completing this estimate, we took each section to a detail. Here's an example of a staffing plan for the facility for our general conditions. We have the design manager for 4 months in the design phase, one project manager throughout the whole design and construction phase, then an assistant project manager from design phase to construction phase. Then we would bring a superintendent in pre-construction all the way to construction phase, as well as an assistant superintendent. Then we have a project engineer from half of pre-construction phase all the way to construction phase. Then we have a clerk from construction phase to closing phase. Then we would offer 2 internships for students, and that would be open for SDSU students in order to support our academic and construction program here at San Diego State. Along with our estimate, we had to do demo takeoffs, steel takeoffs, concrete takeoffs, and other takeoffs for each separate division of work. Here we have a project cost estimate breakdown. For the construction, we had roughly about $10.5 million. Our design fee consisted of a $2 million lump sum amount, and then we decided to add a 15% contingency because of the early design phase of the project. Although in our qualifications we stated that the contingency included was reimbursable, so whatever we would not use for the project would be returned to the owner. Our construction fee was of 2.5%, which added to a total cost of the project for $14,321,252. Our presentation has now concluded. We would like to thank you for taking the time on viewing our senior project SDSU practice facility proposal. Again, thank you.